Hello mathematicians, we're now going to have a look at solving quadratic equations. And the most important word here is probably this one, solving. Because if we're solving, we are going to first of all notice that there's an equal sign written in the problem. It is an equation to be solved. And that we're trying to actually, this time, find values of the pronumeral, which makes that equality true. So unlike simplification, where we were just rearranging and where there was no equal sign in the question already, in this one there is an equal sign and we are trying to find the values of x to make that equal sign make sense. Now the quadratic equation, you recognise quadratics as something with some combination of x squareds, x's, and constants. Or I should say any variable squared, any variable, and constant. So we look before at simplifying them, generally by the process of factorisation. And in solving, we do the same process. And it's that fact that we use essentially the same process, which is often a little bit confusing for people. So you've got to think about why you're factoring, what the process is that you're trying to do, which is to solve. So factoring is the first step. The reason we find factors is if we can find factors that make a product equal to 0, and it's only when it's equal to 0, then we've got an into actually solving the equation. And it makes use of the fact that if we've got two factors, a and b, and their product is 0, then if either a is 0 or b is 0, or both, then that will make the equality true. So if we look at this first one, x squared minus 1 equals 0. Hoping by now your maths brain is screaming at you, write it like that, write it like that. Use our difference of squares. And then the value of x that makes either that or that 0 will make this whole equation true. So we've factorised it, now we're going to solve it. So the values of x which make that true are when x equals plus 1 from the first bracket and minus 1 from the second bracket. Second example, again, I hope your maths brain is saying, do this. Take out a common factor. And then, if a equals 0, or if a equals negative 3, or both, then those brackets will give us a product of 0. Now next one, same thing, we just are factorising. Take 2x outside of x plus 4, so if x equals 0 or negative 4, the equation will be true. Keep going, I won't do all of them, but let's have a look at this one here. So we recognise this as a quadratic trinomial. We know how to factorise that. So therefore we've got 3x all over 3, but we've got this equals 0 on the end, and we want two numbers that multiply to plus 12, add to plus 4, so that would be plus 4 and plus 3. Look for our common factor, so nothing in the first bracket, and if I take 3 outside the next bracket, that will leave me with 3 lots of x plus 1, and that 3 will cancel with the denominator, and so I'm left with this. And now, having factorised this, I solve it. So what are the values of x which make this true? Well, the x value here would be negative 4 on 3, and the x value here would be negative 1. Just be careful with these. Make sure you don't do something silly like I probably would and write negative 3/4. Just mentally substitute back in and see that you do get the brackets equal to 0. Jump down here to this one. While we start off with y squared equals y plus 2, we can't make use of the principle of solution by factorisation until we have something equal to 0. So if we swap all this stuff across to the other side, and get that. Now we can factorize this. So two numbers that multiply to -2 and add to -1. So we could have that. So therefore, if y equals 2 or -1, that will make this equation true. Same sort of technique here and here. We just take things to one side of the equation, get our quadratic, and find the values which make it equal to 0. Now, factorising is a nice process to solve quadratics under some conditions. And that the condition is that we can easily find the factors. But sometimes we can't guess them. You've already come across the difficulties of sometimes getting the right two numbers to multiply and add by trial and error. So if you can't guess them, or they aren't nice whole numbers, they involve surds or decimals or whatever, then we fall back on the quadratic formula. So if we have this quadratic equation, the solutions to the quadratic equation are given by the quadratic formula here, which you've seen before. So notice that this is not giving us factors, this is giving us the solution straight up. We also have a little double check which is sometimes worth using, and we'll do it much more often later in the course. And that is that if we think about the bit which is under the square root sign here, the b squared minus 4ac, the discriminant, which is just the b squared minus 4ac, so it shouldn't have that square root sign. So if the discriminant is negative, there are no real solutions because we can't take the square root of a negative. So sometimes, before we even worry about solving a quadratic, we check whether it actually has solutions. And later in the course, we'll see what the significance is of a quadratic with no solutions. But for the moment, let's solve each equation using the quadratic formula. It says give exact answers. Now, in maths, the word exact is code for leave it as a surd if it comes out that way. We don't put it into the calculator. It also says here, followed by approximations to 4 significant figures where appropriate. Now, because I haven't got my calculator here, I'm not going to do that part. I'm just going to do the surd part. I'm going to give the exact answers. So let's have a look at these. So my first inclination is always to factorize if I can. So I always try. Are there two numbers that multiply to -1 and add to -1? And after a little bit of thinking, I conclude no. So that means that I'll need to use the quadratic equation. I could do this really quick double check to see whether it even has solutions. So b squared, which is -1, minus 4 times ac, so that's -1 squared, which is +1, minus 4 times 1 times -1, that's going to give me a positive. That's all I really need to know. So therefore this does have solutions. What are they? Well, they're given by our quadratic. So it's minus b, so the coefficient of the x term, so that's -1, plus or minus the square root of b squared, so that's -1 squared, which is +1, minus 4 times a, which is 1, times c, which is -1, so that would be -4, so 1 minus -4 ends up being 1 plus 4, and that's all over 2a. So my solutions are 1 plus or minus √5 on 2. I get two solutions, two different solutions, which are x equals 1 plus √5 on 2 and x equals 1 minus √5 on 2. My second example here, same story. Are there two numbers that multiply to +2 and add to -6? No, so go into the quadratic formula, where now it's a c rather than an x. So c equals -6 plus or minus the square root of b squared, so minus 6 squared is that, minus 4 times 1 times 2, so that's minus 8 all over 2. So that's 6 plus or minus square root of 28 all over 2. And although we haven't done the third chapter yet, you might remember from junior school that square root of 28 is equal to the square root of 4 times 7. So it is 6 plus or minus 2 root 7 all over 2, which equals, if I take 2 out as a common factor from this line, then it equals 3 plus or minus root 7. Okay, now this last example, I'm not going to go through that, but I will mention the first line, which is that we can't use this formula until we have the quadratic in this form. So I have to write it as 2b squared plus 3b minus 1 equals 0, so that I have the correct value for a and b and c. This is probably a deliberate tactic on the part of the textbook to give you c as the variable here, b as the variable here, so that you will get mixed up. But just remember, a, b and c are just codes for the number in front of the pronumeral squared, the number in front of the pronumeral, and the constant. Now for these next examples, a couple of points. I'm not going to work them all the way through because I have no doubt that you can use the quadratic formula. The challenge is getting this thing into the layout where you can apply the quadratic formula. And the second point I want to make is that these are probably the extension 1 questions. They're really difficult advanced maths questions. Now they might face these, advanced maths might face these and really struggle. We've got to make them relatively automatic. So let's just look at the process of getting it into the right form. So when we look at this first one here, what we notice is it's got fractions in it. So what's our technique for dealing with fractions in an equation? Multiply each and every term by the common denominator, which in this case is x. So if I do that, I'll have x squared equals 1 plus 2x, multiplying right through by x, then I shuffle it to give me this, and away I go with my quadratic formula. Or perhaps factorising. So once I've done this, I check. For our next one here, same idea. Now you might have called it cross-multiplying in junior school, where you're taking this and multiplying it up there, but technically cross-multiplying doesn't exist. It's a bit like eating lollies. Tastes good, but it's not really good for you. It's not good to think of cross-multiplying. It's better to think of multiplying right through by a common denominator. The end result, of course, though, is the same. So we would get that, then work on that, and we'll get a squared minus a equals a plus 4. And if I bring this a across to here, I'll have a squared minus 2a minus 4 equals 0. Away I go with whatever solution method I can make work. And likewise our last one. Again, we could think of cross-multiplying, but instead think of multiplying each term both sides by the common denominator, which is y plus 2 times y minus 4. And in that case, y plus 1 times y plus 2 times y minus 4 over y plus 2 leaves us with that. And this one gives us that. And you might think, why would I bother thinking more about it? Well, to be honest, 99 times out of 100 it won't make a difference, but we want it 100 times out of 100 that we get it right. Next step, expand stuff out. So that will give us y squared minus 4y plus y, so that's minus 3y minus 4. And over here, I'll have 3y minus 2y, so that will be y, minus y squared, and plus 6. Gathered together, so if I take this y squared over to this side, I'll have 2y squared. If I take this y across, I'll have minus 4y. And if I take this 6 across, I'll have minus 10 equals 0. Now, if I was to factorise this, I could say, well look, I can take out 2 as a common factor. But because of this equal sign, I can do even more than that. I can now say, well actually, let's divide every single term, both sides, by 2. And if I do that, and I get this, the solutions to that are exactly the same as the solutions to that. And the 2 has disappeared in a sense. It's disappeared because 0 divided by 2 is still 2. It's also disappeared because this thing up here is just that. So it's like I could divide that 2 across. And it's also irrelevant because for this statement to be true, I either want this to equal 0, which it clearly can't, or this to equal 0. So my whole task is therefore really just to say, well, I want that quadratic in there to equal 0. And I find that by whatever means I can. Okay, so go to 1G. Don't treat it as just a recipe session. Think about why you're doing what you're doing.